Order of operations, or what some of you may already know as BEDMAS. What do you think of when you hear order of operations? Pause the video for a few minutes and write down some ideas. How does order of operations apply to what we do in math, and how do we use it? Again, pause the video and think about that for a minute. Order of operations refers to the order we do calculations in mathematics. Sorry about that, guys. Order of operations is telling us to do brackets first, then to do our exponents, then to do our division and multiplication in the order they occur, and that's really important. Make sure these happen in the order they occur, then addition and subtraction. That's where the word BEDMAS comes from. The first letter of each of those operations is used to create BEDMAS, which is a shortcut for remembering what order to evaluate mathematical expressions with. Now remember, BEDMAS tells us what to do first, so we can look at the first equation. I consider the expression -5 plus 2 with the bracket 6 minus 4 and bracket all cubed, subtract -3. The first thing we want to think about is what is the correct first step. If I look at the phrase BEDMAS, it tells me I should be doing the work inside the brackets first. So if I look at this yellow one down here, the bracket is still there, the work wasn't done. Same thing here with the green one. So we want to get rid of them. So we're going to get rid of those two. And this was the correct first step, -5 plus 2 times 2 cubed, because 6 take away 4 is in fact 2. Notice that everything else was written out exactly how we see it on the screen. The -5 plus was written down, the 2 was written down in the equation. The exponent, the -3, all of these things were copied directly into the next line of the expression. They weren't changed. When we look at the next screen, we see the expression has the first 2 lines to the solution to evaluating it written out neatly. Now if we look, we've already done the work inside the brackets, because if we look at the 2 with the exponent of 3 and the -3, there's no work to be done or no mathematical calculations to be done inside those brackets. So we look next and we see exponents comes next. And we see that the 2 has an exponent of 3. So if I look at the steps down at the bottom, when I do look at the blue one, it looks like they multiplied the 2 with the 2 in the base. Well, that one's not correct. When I look at the yellow or orange one, it looks like they added the -5 and the 2 together first, and they added incorrectly even. And if I look at the red one, if I grab my handy dandy highlighter, all of that looks exactly the same. All of that part of the expression is exactly the same. The only thing they did was evaluate the exponent. So moving on, we can see that the expression is right here with all of the steps. What comes next? We've done brackets, we've done exponents. Now we look for division and multiplication in the order they occur. And if I look at the expression, I see a sign, I see addition, I see multiplication here. Oh, that's the first one I see, and then I see subtraction. So if I look at this, -5 plus 2 is -3. That's what happened in this first red expression. We don't want that. The orange expression, -5 plus 2 times 11. They added 8 and -3. We don't want that. And in the blue one, -5 plus 16. Well, 16 is really the 2 times 8 we were looking for. So that one's good. So now our expression, evaluating the expression, we can see a nice solution being created as we go through. We need to know the fourth step. Addition and subtraction, we do them generally in the order we see them. However, they don't have to be done in that order. So let's take a look. If I did the first one, -5 plus 16, that would give me an 11, and I would have to have subtract -3. Oh, wait. That happens right there. If I look at the red expression, Negative 5 plus 16 is most definitely not negative 21 because they don't have the same sign. I can't add them up and get more of them. And negative 5 plus 13, well, 16 take away negative 3 is not 13 because 16 take away negative 3 is 19. So we're going to get rid of the blue one. And now we have the solution and we want to know what the correct answer is. So remember, when I do subtract a negative, it's like putting a 1 in front and multiplying. So that negative 1 times negative 3 becomes positive 3. And the answer is, in fact, 14. We're going to get rid of the 8. So if we evaluate these expressions, we need to think about what comes first. Brackets first, so we're going to do that step first. Notice how I underline every step. In the next line, you see the exponents get done next. So negative 2 cubed is negative 8. So everything gets written down exactly the same. When I do look at negative 2 times negative 8 and 3 times negative 8, they're both multiplication separated by an addition sign, so I can evaluate them both at the same time. And a negative times a negative is a positive, so I get positive 16. And a positive times a negative is a negative, so it's negative 24. And there are more negatives than positives, and there are 8 more negatives, so the answer is negative 8. Pause the video and try and do this question on your own because it's going to incorporate integers work, order of operations, and rationals. So pause it now and then start it again when you've got a solution that you think is correct. In order to do this, we have to remember brackets first. Inside the brackets, we're subtracting 2 fractions. The 2 fractions do not have a common denominator, so the first thing we have to do is create a common denominator using multiples. And your multiples of 3 are 3, 6, 9, 12. And your multiples of 2 are 2, 4, 6, and 8. So your least common multiple is 6. So we're going to turn the 3 into a 6 by multiplying by 2. And we're going to turn the 2 into a 6 by multiplying by 3. And we're going to do that to both the numerator and the denominator. Now they have the same denominator, and we can simply subtract the numerators. Now looking at this, we've done the brackets. The next step is look at the exponents. We have to remember that 1 over 6 squared means 1 over 6 multiplied by 1 over 6. And if I multiply the numerators, that gives me 1 over 36. Now I need a common denominator, and the least common multiple will be 36 because 4 times 9 is 36. So I only have to change one fraction, and now I'm adding. The denominators stays the same, and I can add the numerators. Negative 9 plus 1 is negative 8. And I should remember that I always reduce to lowest terms where possible with fractions, and I can divide both of these by 4. And the answer becomes negative 2 over 9.